Hello and welcome back, and that is right, today we are revisiting the ZimaCube, in this case the ZimaCube Pro, and in this video we're going to be looking at Plex Media Server performance of this crowd-funded device. Now for those that aren't aware, the ZimaCube from Ice Whale is their third crowd-funded NAS device. It's currently been shipped to early backers. There was a standard version that arrived with an N100 CPU, and this is the Pro version. It arrives with an Intel i5 12th gen CPU, and we've got a full hardware review that, if it's not already live, will be live very soon. But this video is just about how well this system performs in Plex Media Server, hosting your media on this device. Now before we go any further, a few disclaimers straight out the back. Number one, we are using the Plex app that the system arrives with. It's a containerized application in the App Center. You can go ahead and install. We've already given it all of the system access that we need to give it with regards to media, with regards to hardware, the works. No limitations whatsoever. We are accessing the device locally to remove any kind of bandwidth restrictions. So for example, we are accessing the ZimaCube right now over the Thunderbolt connection, something I'm really enjoying, and that means that because we're accessing it over Thunderbolt, it means we have got a larger network connection. We're actually got 20 gigabits per second to play with there, which is, although half what technically Thunderbolt 4 is, that's still more than enough bandwidth for our media. So there should be no bandwidth restrictions whatsoever throughout our testing. Also, we are going to be taking advantage of transcoding. We have set utilizing a Plex Media Server pass, or a Plex pass. We've got Make My CPU Hurt, and at the bottom we are using those integrated graphics that make up part of that CPU. So we've got plenty of hardware at our disposal. Next up, we will be accessing the ZimaCube Pro in both the web browser and using the Plex client. We're going to be doing different kinds of tests, and I think different tools are going to be more useful in this test to sort of demonstrate. To give you an idea of what I mean, here for example is an 8K media file. We're just going to play the 8K media file that this system I've already bunged on here, and as you can see, we're playing back in original quality here on the client device. We're seeing plenty of buffering there on the bottom of the screen, and if we head over to the ZimaCube's dashboard here, we'll be able to see CPU utilization. There's the original file being played, and we can see, although bandwidth utilization has leapt up at one point to 778 megabits per second, CPU utilization is pretty darn low. Now to put that into perspective, if I try to access that exact same file here in the web browser, bear in mind that Plex right now is using 101 megabytes per second, 101 megabytes RAM, as you can see at the top there in Chrome. And if we look at utilization here on my local machine, from the GPU all the way through to the memory, let's play that same file here in the web browser. As you can see, it's automatically had to convert that file. Now the conversion there can be for numerous reasons. It can be for reasons of compression technique. It can be for reasons, compression technique known as HEVC versus H.264, something we've covered in other videos. But on top of that, it could be the sheer weight of the file. It could be hindrance to the local system. It could be the audio. There's lots of reasons. Indeed, in the background, you can probably hear the fans on the ZimaCube starting to peak up. I'm just going to move the mic closer to the fan for a moment. So as you could hear, the fans on the system have leapt up because of a lot more work happening with that GPU. And although it is playing, and it is playing with conversion, CPU utilization has now gone up to 14 to 15% there. If we go onto the net data there, we can see higher utilization of CPU during this test. So some tests are going to be performed on the client, and as you can see, it's even hit a buffering issue here, and some tests are going to be performed in the web browser when we want to test with and without transcoding. So let's crack straight on with our tests. We're going to go straight into some 1080p files here. This is a nice easy file. This is a 3 megabits per second HD file. As you can see, playing in original quality. This is an H.264, so no licensing issues here on that file. Playing back absolutely fine there. So we'll come out of that one. Now we'll do the exact same file, this time in HEVC on the web browser. As you can see, playing the original quality, no issues with HEVC support there, and you can see playing back absolutely fine. what if we transcode this file? Let's convert that file. So we'll convert it here on the fly. It'll take a second or so for the thing here on the right to show us, but as you can see, that HW there next to HEVC main and above transcode, that means this is a file that is being transcoded with hardware. We are using the hardware utilization, but we did see a significant spike in utilization. Now, this is going to be very important later. As you can see, this rather simple file, which was dense, I'll be honest with you, it is a very dense file, we saw CPU utilization go up to 84%, or 83% for Plex. Now, that's because in numerous tests I've done with the ZimaCube, there's definitely optimization that needs to be done here, and it's one of the issues you may encounter when running containerized applications which need very specific access to the hardware resources, but also the ZimaCube's own OS, ZimaOS, needs to have better optimization of the hardware, which is one of those things that just takes time. You look at Synology, QNAP and all of those brands, the amount of oomph they can get out of average hardware generally gets better over time. And that's why, although you are going to see this issue with the CPU several times in this video, I am going to say that from what I've seen of the ZimaOS updates, they have been optimizing. Is it enough yet? Well, we'll have to wait and see. But let's go in. So we've played that 3 megabit HEVC. Let's jump up significantly. We're now going to go to a 30 megabits per second HEVC file. HEVC, or highly efficient video codec, is a much better compression technique. It was kind of pioneered via private industrial consortium of multimedia organizations to put together a better compression technique to make movies in the cinema be watchable in the home. The one prior to it, H.264, was considerably more available. It was effectively open source, whereas HEVC is a private licensed compression technique that, although is very, very common, does require client devices and or server devices to have it. That's why more often than not, when you play them, you'll be faced with conversion there. So immediately this has gone into a conversion, and as you can see, you might hear the fans on the system peak up. We're seeing that CPU spike up. We're seeing transcoding there happening with the hardware, and we're seeing that spike once again. Now keep in mind, this is just a 30-second file. That's why the spike is brief. Now, if this was a feature presentation, that'll be a slightly different story. We will be moving on to longer files in just a moment. But just for a sense of perspective, now we're going to look at, again, those same 1080p files, but this time we're going to play them here native. So we're going to go straight into HEVC there. We're going to play it. We've got no conversion. And as you can see, 30 megabits per second HEVC, no conversion this time because the client device doesn't require it, which is more likely the case with a lot of your devices at home, but not all. So always check if you have an HEVC or H.265 license on your system. As you can see, no issues there at all with the CPU. So next up, we're going to move into 4K files. Now these are exceedingly dense 4K files. So we're going to come back to these in just a moment. We're going to go into my 4K test files here. First one, Into the Cave of Water. Into the Cave of Water is an H.264 4K file, MP4, but as you can see, we require conversion. The weight of this file, perhaps something to do with the audio codec. There's any one of a million reasons why this might be kicking off here. We can find out more information about it within the client tool, but as you can see for now, this is a 8-minute 54-second file, so none of your 30-second stuff. And what we're seeing now is that CPU consistently high. This file technically isn't as hard as some of the conversions that we've committed to this point, but now we're going to see that CPU living at around 27 to 33, 35% consistently during that playback. Now, again, we could come out of it. This time, we'll go in and play that same file, and we'll see if we play the native version, if it will allow us. And as you can see, now we're playing the native version. Once again, we can skip ahead. It's going absolutely fine there. And as we can see, CPU, it's gone up to between 6 and 10%, depending on whether it's the system or not. Skipping around, kind of taxing the system a little bit there. We will be doing multiple file input output in just a while. But as you can see, playback, pretty darn good. So if converting and transcoding isn't really your bag, this is all great news for you. Next up, we'll go to roast duck. This is a denser file here, 60 megabits per second, 8-bit HDR 256 HEVC. It's an MKV file as well. This is not a tremendously heavy file per se, but I will say it's not the lightest. As you can see, it's only 42 seconds, but once again, we're seeing that CPU utilization go up there to between 31 and 33%. So again, not small numbers, but not end of the world numbers, as hopefully we'll see Zima/Ice Whale do some more optimization there over time. And again, not that we have to, but just for the last time, we can go in, we can see native playback, we're seeing original, we're seeing it. But while we know this is going to work in original compression technique, what if we give ourselves kind of a hefty bit of transcode? We're going to take this 4K right the way down to a 2 megabit 780p file there. So it's going to have to rebuffer all of that data. But luckily, because it's the client app, it's going to hopefully be a lesser load on the system. But I will say that buffering is not going far enough ahead than I'd like, and CPU utilization is already creeping up. And the fans on that system, as I'm sure you can hear by now, have certainly let up. So now we return to those denser 4K files I mentioned earlier on. Again, we'll go for something easy. This is a 120 megabits per second 4K Ultra HD H.264 file. Obviously, it's a weighty file, so once again, we're seeing that conversion happen. Interestingly though, this is still doing a good enough job. Now, 120 megabits per second, that is the bit rate. That is how much data is being transmuted per second. Transmuted, not really the right word. Being transmitted. Now, keep that in mind. That is a very caveman explanation. But ultimately, higher dense media tends to have a much higher bit rate because they're putting far more data per pixel into every single frame in those seconds. As you can see, played back fine. Next, we'll go into the H.265 version. This is a 10-bit HDR version. This is going to be a little bit harder work for the system. I'm hearing the fans on the system already eke up again. We're seeing that CPU utilization, but we saw a larger hang there at the file playback there early. Now, keep in mind, very few users have this kind of size media in their collection. Most media that you buy is going to be, when you buy it retail or when you rip from a Blu-ray, more often than not, in its base level form, you're looking at between 12, 16 megabits to maybe 30 megabits per second, peaking at around 50 or 60 max. These files at 120 are not domestic files, so it is no shame if the ZimaCube doesn't play them, but I will say with its i5 internal hardware there and playing on that largely bandwidth free Thunderbolt connection there, I will say I'd like to have seen slightly better results than what we saw there. Let's get rid of that, and go back in. So next up, we'll move over to the 200 megabits per second. We're going to skip H.264 and go straight into the 10-bit HDR H.265. Again, converting down to 1080p. If we look at the options that we could have gone for, there are others, not huge amounts, but as you can see, it's playing. The memory utilization on this particular tab has gone up to 126, and it's 189 on Zima's own OS. And if we have a look, CPU utilization and load is getting creeped up all of the time, unsurprisingly given the kind of test that we're performing. But nonetheless, it still managed that file, and I'm sure if we flick over to the client app, go into our 4K test file, scroll down to the bottom, 200 megabit HDR, playback, original quality. As you can see, it's doing fine. If we look at my local PC, we can see network utilization there. We can see the GPU on my local PC is handling a lot of that because of the client app, taking some of the load of playing that file. But nonetheless, great numbers there from what I am seeing. Lastly, we can make our way to the 400 megabits per second file. Again, the majority of NAS devices aren't even able to play this file. I will say this is a 400 megabits per second 4K 10-bit HDR HEVC file, and it's trying it. Fair play. The buffering there is ahead of the playback, I will say a similar architecture NAS to this, the QNAP TVS H874, was able to play back this file multiple times, but because this is running a conversion on this file, I very much doubt this is going to be able to do it. As you can see, we're still using hardware transcoding, but as we go down, CPU utilization is still pretty big there. So why don't we run a few conversions on that big file? Let's open this file up in a new tab. Open that tab out there. Bring that down. We're going to run this hefty file 3 times. So let's line it up on all 3 systems. Let's get it there. And we're just going to play this file on all 3 simultaneously. So we'll get that one playing, that one playing, that one playing. We'll move that over. And we look at the CPU utilization. All 3 instances, as you can see, have been recorded there. If we open it up, we can see conversions. We can see conversions, and we can see native playback there. I've just paused it by accident. As you can see, it is playing. It just took a little bit of time to play catch up across these different media format files there. Overall, I'm happy with what I'm seeing there, but CPU utilization is a mite higher than I expected for a system of this caliber. I would have thought with this kind of caliber, I would have happy to have seen maybe 33-35% utilization there. So finally, we go over to 8K. We're going to go to some 8K files there. Let's close that window. That might lead to that file remaining here. We're just going to stop that playback. That may hang around on screen for a little bit of time. There's not much we can do about that. We'll go to the 8K media, and we've already tried Helium Fire. So let's go for Japan 8K. As you can see, straight away, unsurprising, straight into the conversion. We're going to see bandwidth utilization creep up. We're going to see CPU utilization creep up. We're probably going to see RAM as well getting spiked up a little bit there. And if we have a little look at utilization on my local machine, we're looking at 25%. Memory utilization by Chrome has gone up to 128 meg for this file. But as you can see, playing 8K in a web browser is a pipe dream a lot of the time. It's just simply not a viable option. So we're going to leave that. But as you can see, playback is only barely, if you look at the bottom left, barely ahead. Buffering is ahead of playback, and it's going to pause the file in a second with the orange ring of stalling, as you can see there. So again, we saw CPU utilization maintained at 14%. Bandwidth, there was a spike, but not too much more than that. What if we play it local? So let's play that file local there. As you can see, we're playing at original quality. We're leveraging, as you can see, we're now playing 8K, and my GPU is going absolutely bananas because it's leveraging my system local client hardware rather than the NAS. But as you can see, local domestic playback, absolutely fine there. So I'm going to play one more 8K file in the web browser, even though I think we can all agree there's no point. We're going to go for Patagonia 8K. As you can see, straight into the conversion, unsurprising. And if we have a little look, minimize there, have a little look. It's going to try. CPU utilization is creeping up again. But once again, the issue with 8K a lot of the time, particularly we're seeing a lot more impressive codecs arrive on the scene for 8K, is that things are getting more complex, and Plex itself with 8K is just not there. So if you are thinking of playing 8K, you're going to hit these problems where converting to non-8K client devices is just, the buffering just cannot outpace organic playback. So we're just going to keep encountering that problem there. Again, not the end of the world, at least now, as we see more impressive client devices, which we've already seen, where you can leverage local hardware for those conversions, but at least converting for transcoded access is going to be limited there. But unsurprisingly, if we make our way into, let's remove that camera there that I've just accidentally clicked in, minimize that down, we don't want that affecting our results. We'll go into there and we'll try Patagonia again, this time using that client app. And again, within the client app, plays like a dream. And it's a real shame we can't run multiple instances here. I could access this on my phone or another device. And again, we could see that. But I think comfortably without transcoding, we can make educated guesses. We're watching an 8K file being played natively. We're seeing that CPU remain at just 0.65% utilization with Plex and just 3% with the system. I think the big takeaway in today's video is, as long as you're not going to be reliant on transcoding for now, The ZimaCube Pro is a great little Plex media server NAS. I'm happy to say that, but I will say that it definitely still needs further optimization, particularly with systems accessing a lot of the transcoding engines, the GPUs, the CPU, and Zima OS is a very light operating system. It has to be said. It is effectively just a container skin. A lot of the options that you see on it are arguably quite limited compared to that with other operating systems. It is designed as a light gateway, with containerization being the primary method of utilizing the system applications and newer programs on this system. Yes, you can configure some of the settings, but this is the full settings menu. There isn't a lot to play with there, so you've got to keep that in mind. They've added things like VMs, they've added things like a file manager, which arguably I would say is still not as good as a downloadable one. You can use a TTYD bridge to access SSH. They've added things like PeerDrop. They've added that client tool that I showed earlier on there on screen, a lovely little tool for finding the device, configuring it. Great stuff. But I still think there's further optimization to be done, and as we've seen throughout this video, I think when it comes to Plex, for now, if you're going to be using native playback, no transcoding, no conversions, you're going to be laughing. But for those of you that are going to be leading onto that, that may be something you have to consider and keep an eye on later down the line when this system has completely finished its crowdfunding fulfillment and has moved over to traditional retail. But this has been Plex Media Server testing of the Icewell ZimaCube Pro. Let me know what you guys think in the comments. If you found this video helpful, fantastic, do let me know. But apart from that, there should be an article with this soon, and the full review of the ZimaCube Pro should be with us, if not already live, then very, very soon. But apart from that, thank you so much for watching, and I'll see you next time.